and welcome to this OpenShift Anwendertreffen. Today in two stages. Here we are on the second stage, on the Zurich stage for this DACH event. With me here I have Raffael Hertle from Puzzle, who will tell us today about microservices, Quarkus and OpenShift. So yeah, please, a round of virtual applause for Raffael, and I would like to hand over to him. Off you go.
Thank you very much. Hey guys, welcome you to my little talk this afternoon to kick off the afternoon session, which is called the Microservice Story. And I'm going to talk about an architectural transition with ease powered by Quarkus and OpenShift. So, first of all, hello guys, it's very nice to meet you. My name is Raffael Hertle, software engineer with Puzzle ITC in Bern. I focus mainly on microservice architectures, especially with Quarkus and OpenShift. And I'm really glad to be here to talk to you. I'd also be really glad if you would hand me afterwards some feedback, please, over Twitter or via email. So you have my credentials here on the slide, because it's always hard to make a remote talk because I cannot see your facial expressions here. So I cannot tell whether you're falling asleep or you're having tears of joy here. So who are we? Our company is called Puzzle ITC. We are an open source company headquarters in Bern. And please don't panic, this picture was taken before the pandemic, so no face masks here. We're around 140 members working in the company. We're focusing on software engineering with Ruby on Rails and Java. We're doing a lot of system engineering, and we do have a user experience studio. Our focus lies mainly on cloud-native centered technologies. We're doing a lot of container, Kubernetes, and OpenShift engineering as well. And we do have a main focus on Linux. And one thing we do, which connects us, we do love open source. Yeah, I think that's why we're here at this user meeting of OpenShift as well. So what I'm going to tell you about you this afternoon. So first, I'll have a little story time. I'll talk about what I call the great refactoring, which is just an experience from a project of mine working with microservices and coming to Quarkus. Then in the second part, I will talk about microservices a little bit in general. I'll explain a little bit theory, dive into some details. Yes, and at the end, I'll do a little recap, talk about technological changes and the experiences we made during this transition. Well, yeah, let's start with a little story time. Well, maybe to start off, I need you to understand like the base scenario of our project. So in Switzerland, we had this energy law reform, and after 2017, in 2018, it became new that households can form and create so-called self-consumption communities, short SCC, together. And they now have the opportunity, instead of selling all the produced energy by their photovoltaic devices, for example, they can trade their energy within their households. So instead of going back to the energy provider, households can now trade the energy or sell the energy to other people in these SCC. So as you can imagine, these sales and billings, they need a lot of paperwork. So it got an extra effort for all these people using this system. And another problem we had, or they experienced, was that the distribution of the energy, whether they consumed from the net or from the photovoltaic energy, was not transparent at all. So there was a pretty clear use case. So the households, they needed a solution to allocate and bill the energy produced by them and trade it within these SCCs. And they also needed, and they want to have a build platform to manage these SCCs, the members of it. They want to have the energy data built, and they want to be transparent. So if you thought about it, the central process of our application or idea was pretty simple, right? We had somewhere we had to read the energy data from smart meters. We had to store the data, display them on fancy dashboards, and after the end of the month, we had to build the data to the user. So sounds pretty easy, right? Well, after having a use case, two major companies in Switzerland, they founded this innovation project to tackle this problem. And to be innovative, of course, you need a lot of technical buzzwords. So we had to use we used a blockchain technology to store data to be immutable and transparent. And we also had this Internet of Things IoT approach because, yeah, we read data from smart meters and put them into our system. So I gotta say, it was a very interesting use case with a very clear idea behind it. So what happens next? Well, the first idea was to build a prototype to fit the use case and make a proof of concept that we can read the data and build the energy to the users. So the first meetings, they may have looked like this upright. So it was one person telling the idea. And yeah, so for prototyping reasons, we chose a monolithic approach to tackle this. Well, due to speed reasons, we decided to use a JHipster framework. It is a bootstrapping tool for building fast Spring and Angular projects. So we use this to set up a prototype, and I gotta say it's very useful for fast setups and for prototyping. And I cannot stress this enough. It's good for prototyping, and I wouldn't recommend using it anywhere else. And we had our application run, obviously containerized and orchestrated with OpenShift. So after a while, the usage of the prototype led obviously to happy customers because they could now build and see their energy on a web platform, which was entirely new instead of making all by hand. And we experienced that the system was really running smoothly on OpenShift. And we saw, or let's say the managers saw, that there was true market potential here. So we have to say that our proof of concept was successful after some time. And when you reach that stage in a project where you had your prototype or your proof of concept, and you have a market potential there, there's only a matter of time where you want to switch to a real product, right? So you want to transition over from a prototype version to a real product. And at this stage, there was only one question: it was how do we transition over to that? So we had a lot of discussion about any migration path, or how do we achieve becoming a real product after the prototype. There were the possibilities to use the prototype and just continue working on the prototype. We could have worked from scratch or started from scratch, or we could have made a mix of both. And well, we had a lot of discussions, and obviously due to financial reasons, and yeah, we decided to reuse the code base. We told ourselves that we would do some refactoring and reordering inside the project to make this prototype neat. Well, you can only imagine what happened, right? From a prototype going into a product. Well, born was the prototype, like I like to call him. And I think this was the prototype was little Frankenstein down here, and I think he was pretty happy to be kept on running, be kept alive. So, well, during the transition to a real product, the user base it grew obviously because we had happy customers, we had new customers, and with a growing user base, you can only think that behind there the inbound readings or the readings we consumed, they multiplied. So as the readings and the user base grew, well, the code base and features, they grew similar. So after a while, we had this pretty big ball of mud. And you don't want your application to become a big ball of mud, believe me. So after time, we decided to transition over our architecture a little bit. And yeah, we all knew about this microservice approach. It sounded really interesting. We had some discussions about it, and then we decided, yeah, let's try this. Let's tackle this problem, and yeah, let's go for a microservice-like architecture. So we sat down and we split up our application into 4 main business domains. So I guess we wanted microservices, but what we did was we created these little micro-monoliths. So after a time, we split our main application, our monolith, into 4 smaller domains. These are these little 4 Frankensteins or micro-monoliths down below. And they were separated by business domains. So we were driving a split by functionality and business. So how did we achieve this transition, going from a application from a monolith to a microservice architecture? Well, we thought about just replacing all the function calls within the system, going from one domain to another with simple REST calls, right? And I think the idea was pretty genius. Well, that's what I thought at first. Then the next discussion came up. We had this pretty big database, right? We stored all the user data in there. We stored all the readings and all the prices for every reading for an interval of 15 minutes for almost a year. So we talked about migrating data, and well, this was one of the bigger mistakes we did, because we decided to share the database between these 4 micro monoliths. Because it was simpler to just copy the models, and it was an easy migration path. But we gotta say, it led to really, really tight coupling and, well, obviously heavy dependencies between these 4 little Frankensteins here. So another problem we had with this shared database is that it led to ridiculous startup times. Because there was one main Frankenstein who had to initialize the entire database, and while the database was initializing, all the other Frankensteins could not connect to it. So they all had to wait. We had up to 100 or 120 seconds of startup time per microservice. So this was a ridiculous time to wait. And suddenly all the deployments became a real struggle. Well, but after all, we got to say that the system, for the customer, the system was running stable. So on the other side of the project, not behind the technical curtains, you had the customers being happy. And we got to say the system was stable and the load was manageable. So, well, the same thing happened again, right? We had a stable system, we had happy customers. Happy customers led to more customers, which led to more meters. And well, with more meters, we couldn't scale anymore, and we couldn't follow the load anymore, or couldn't scale in the right dimensions. And one big problem we had is with these REST calls and this shared database, we had an entire blocking operation in our entire workflow. So we had, for example, we had this fetching readings, fetch metadata, do some calculations, persistence, all in one single blocking workflow. So as you can imagine, running in a micro-monolith or microservice architecture, this created real huge bottlenecks. So after a while, we realized that someday we cannot tackle this anymore, or we have to tackle the bottlenecks now, because these blocking services and these big services, they really are going to kill us somewhere. So we thought about how we could go better, and we talked about this, and we set as a goal that we should get smaller, and if possible, we should get more reactive in the system, because if you're going reactive in a distributed system, this means that you're losing coupling a little step more. So in the end, our final goal was to create robustness against big peaks of performance, for example. In parallel, there was the project Quarkus coming up. It was a very interesting project with promising concepts. A really good friend of mine told me about it, and I was super excited to read about it. I read about it. It was this like Apex cloud native technology, which sounded super interesting. And one thing that really I'd like to mention it, that it focused on standards. So it was really exciting, and I read about this fast startup times and low memory footprint. And I know exactly the only thing I could think about was this meme. So, well, the underlying fear of mine, or I think of many people, was just that, yeah, well, it's fast, but nothing else, right? You have to do some trade-off, or get some kind of trade-off for being just ridiculously fast. So I dive in. Well, I tried some tutorials. I checked some code examples. I did some work on my own, and I really got to say, I was amazed by the overall quality of the documentation and the project by itself. So the next stage is that Quarkus became like this hot crush you have on someone, right? You see this on this picture here. I was turning around from my Spring development. I was looking at Quarkus all the time. And as you can imagine, in this scenario, I wanted to talk about it all the time. And after some time, I wanted to use it. And I had this idea that I wanted to use it in production in our project, because after all, well, getting smaller is like the main goal of Quarkus, so it could solve all my problems in this project. So what do we do? Well, I started my personal little proof of concept with Quarkus, migrating our project over to smaller microservices powered with Quarkus. I did in this phase, I did a lot of testing of neat features of Quarkus. I tested the native builds, which promised and showed very fast startup times, which were really genius. I tested the reactive messaging, the integration of SmallRye, but there I ran into some problems with all the blocking operations we had in our database. And we also tried this reactive REST approach. It was very interesting, but it was not easy to transition from one-to-one from an original or old way written REST interface. So the idea was pretty clear. After some time, I tested it and I said, hey, my personal proof of concept was successful with Quarkus. Well, I loosened the coupling drastically. And one of the most important thing in this entire scenario, that during the phase where I showed the team and involved everyone, had so much fun working with Quarkus, and I think that's very important at this stage. So what we did, we started to develop in parallel to our original project. We worked on a microservice approach with Quarkus. So what we did back then was we transitioned to this new microservice architecture with this strangler fig approach, which I'm going to talk about a little bit later. So after some while, we did this transition. So we had a transition over to true microservices, or yeah, how I'd like to call them. These were pretty small autonomous services. We tried to make most of them stateless, and after all, they were very much more independent from the old ones. And what was really interesting was that our landscape suddenly grew from 4 micro-monoliths into 14 microservices. This was like an exploding factor between them. One important thing we did replace most of the synchronous workflow by replacing it by a non-blocking workflow through or powered with messaging. So after time, or after this transition, we realized that we were finally more robust against peaks, because with this asynchronous and reactive approach to messaging, we were more reliable against peaks. Another thing we realized is that with these fast startup times and smaller non-dependent microservices, our deployment was much faster and much more fun to do even. When we watched at that stage, in comparison between the two projects, we realized that the new project with these 14 services was like cloud native at its bestest. So I gotta say, it felt real good. On the other side, as you can imagine, transitioning from 4 to 14 services needs a lot of attention and extra effort to operate. Because when I say 14 services, I'm talking about 14 logical services without even debugging infrastructures. I think it was more about like 24 or 26 services in overall in OpenShift. So we had other infrastructures elements, as you can think of, like databases, message brokers, etc. And one thing we did really good or really well from the beginning of our project, we held our infrastructure as code, and I think that really helped us really a lot. So in this next stage, we went a step further and we created a new repository only with the infrastructure as code. And one thing I really liked about the way we did it, or the way we handled business, was that we automated most of the work. So we had automated scripts for setting up new environments, copying databases, dumping databases, etc., etc. And with the help of OpenShift, we could create parameterizable scripts to automate this work. So, as I said, with these faster startup times in the microservices, we could now benefit from the opportunity to scale finally in a system. We could scale from in need. When we needed more resources on microservice A, we could simply scale it, which was not really possible before. And another thing is that OpenShift promises to be a self-healing system, and it really is, but it was only when our microservices got so small that restarts really helped. Because when you have microservices which need like 100 and 150 seconds to shut down and the same time to scale up again, you will running into problems with this self-healing system. But now with these true microservices, it was really working well. So another thing I got to say is that OpenShift really allowed us to build a transparent landscape, because health and statuses of pods and services were so quickly checked. And one thing I really liked is that the points of failure and weaknesses were identified pretty well and pretty fast. So, but I gotta say, we generally invested or did make a big investment into our observability stack, and I gotta say it's worth it. We had we have neat little dashboards to tell us about our metrics. We have so many metrics exposed in our service. And we do have this nice log aggregation in OpenShift, which brings me to the next part, which is the only thing that connects lumberjacks to programmers, right? The obsession about logs. So, yeah, well, a little recap. What we did was just a simple transition from monolith to microservice, and I think what really got us there was that we are very aware of our requirements. And one thing we really did, or we were able, luckily, to do, was to fail fast. So we could try out new technologies, we could fail, and we could adapt to the situation. So let's skip over to the next part. But I want to talk a little bit about microservices. I had like now 20 minutes of talking about them and didn't lose about the word, what are they exactly? So what I now want to talk about is, what are these microservices and when and why should you use them? I always want to talk a little bit about advantages and disadvantages and maybe pitfalls from our experiences. And as I said earlier, I want to show you this little approach to migration. Well, so let's start up first with, what is a monolithic architecture? Well, in this image you have the UNESCO Heritage Site. It's a house in Saudi Arabia, which is pretty interesting, I think, and I like this real-world analogies because this is literally a monolithic architecture, right? It's a single stone house, which makes it monolithic. So if you think about this, this could also be a software system, right? And if you want to replace or even relocate the kitchen in this house or in this thing, well, yeah, good luck. Think about it. It's getting pretty hard. So what are the key descriptions of a monolithic architecture? Well, I think a monolithic architecture is held as a single code base, right? And one of the most important things or key things here is that the monolithic architecture application is delivered and deployed always as a single unit. So we realized that suddenly the lifecycle of all our units is connected. So if you want to change one piece, like in the example before with the kitchen, you have to roll out your entire system. And as you can imagine, this gets very expensive after some time. If you always have to put on a new rock somewhere, just because you have to repaint your kitchen, it gets very expensive after some time. And another thing is that this monolithic application is a self-contained application, and it's mostly independent from other systems. And what really describes the system is that it can perform all tasks of a needed process by itself, so it doesn't rely on anything else. On the other hand, we do have this microservice architecture, which I mentioned like 100 times before in this talk. So if you think about the monolithic house before on this illustration on the left side, then microservices are on the right side. Think about it that we split like separate domains into separate services or applications. So suddenly the kitchen or the recreational space, bedrooms, they become single services or small applications. And they're independent from each other, right? Because why the hell should the kitchen care about your bedroom or the other way around? So I think, but I gotta say, after all, microservices are pretty hard to define, because when do you get enough micro to be called a microservice? But there are some key points which I want to point out. I think that most important, it's a small and autonomous application. And microservices in a multiple or in a horde, they have independent life cycles. And you also have, or should have, or try to have single services for a single responsibility or for a single domain. If you think about it, microservices, they loosen coupling between your system. And one thing you can have is that, or should have, is that you have a code-based per domain or business process or even per service. So the next thing I said I'm going to talk about is when to choose which architecture. And be a little cautious here. Maybe this is they're just my or our impressions, and do not follow these guidelines blindly. But let's take a look at this example. We're starting out with a new application, and this development starts, and we think about it as a monolithic application, like in the example before, right? So we do have this monolithic application which is developed by only one dev team. So it was very similar to before. We have this small project, we have a small scope, and we have a small team. Now you can think of the advantages in this case, right? So the advantages of a monolithic architecture, well, they're pretty obvious, right? You have everything local. Everything is held in the same code base. You can start the entire application and test it within one component. One thing you have here with this small application, small team, is that you have a high productivity, because all the components are developed in-house, and which just higher your productivity, obviously. Well, another thing is that you have a less open structure in your application, which means that you have less attack vectors for your system. And one thing I already mentioned is that it's easy testable, because you don't have that many external dependencies. You can start your entire application and test it through from one end to the other. And I think at this point, the performance, it matches the requirements pretty well, right? Let's look at the advantages maybe for the team. Well, for the team, you have a dedicated team for a single application. You also have this, because of the increased productivity, you can release and develop features faster. And one thing you have is you have no dependencies to other teams, so your team can just work without any communication overhead. And also, a very big key point here is that the developers, they have a big knowledge over the entire system or the entire application. So what happens after some time? Yeah, the same thing that happened to us. After some time, your application gets maybe a big success or a mediocre success even. Then what happens? The user base, it increases, right? So what does that bring? It brings automatically more traffic to the system. And with that, or with more feature users, you will automatically to implement more features to the application. So the natural thing to happen with all these increasing user base, traffic, and a lot of feature requests is that your dev team grows. And all of a sudden, without you even realizing, your application or your project just might look like this. Well, as I said in my example before, this well-structured monolith or application suddenly became this big ball of mud you didn't want him to become. So you have your 4 dev teams working on the same application, all creating conflicts all over the place. This is what brings me to the disadvantages here. So if you think about this, well, architectural changes at this moment, it becomes almost impossible in this situation. And one thing you also have to think about is that impact of code changes in the system could make impact in the entire application. So another problem you have or you're facing is that keeping up the quality of your code or quality of the project in general, it brings up a lot of extra effort. And a last thing I want to point out here is that upgrading or updating your application to newer technologies will become very, very hard and very painful, as you can imagine. So what's there with the team? Well, obviously the coordination for the team, it generates way more overhead. And co-working with these teams, it will end up in collisions. So the problem is that feature releases, they get suddenly more complex and they need to be well structured and they need to be planned in every detail. So after all, this leads to feature freezes you have to do and also to longer release cycles. And another point which we had as an advantage of monoliths before is that suddenly the developers, they have the limited knowledge. They cannot know the entire system anymore, right? And what happens then? Well, obviously the productivity drops all of a sudden. And that's what you didn't want to have. So now what? Well, a possibility you could do is microservices like illustrated on this picture here. You could split up your application and have your dev teams working on smaller projects or smaller little applications. So let's take a look at the architecture here. With these independent modules, they become independent services, right? You will have to have your boundaries or APIs well defined. This, after all, loosens the coupling of the entire system drastically. And one thing, our advantage of this thing is that you could go for a polyglot culture. I mean, every team, they can choose their preferred stack if they want to. Let's take a look at the advantages for the teams. Well, the teams, they might work independently and they can have agreements on defined boundaries, what we call contracts between these services. All of a sudden, the teams, they have bigger knowledge of their defined little scopes of the applications. And after all, this brings way more faster onboardings for newer members or newer devs to the teams. We can also take a look at the advantages of the runtime and deployment. Microservices, they can and should be deployed independently, right? So all of a sudden, as I said before, scaling of single components suddenly becomes possible. So you can scale on demand only one side of your application, not the entire application. And one neat little thing is that bugs may not affect the entire system. But everywhere there's also a downside. As you can imagine, we have also disadvantages in architecture because the point we pointed out that monoliths, that everything is local, is just not true and does not hold anymore, right? So you have everything distributed now. And the distribution of data, it brings extra pains with it, right? You have to share foreign keys over boundaries. And suddenly holding consistency becomes very hard in this software system. And obviously more distribution in your entire architecture, it brings more communication. More communication always brings more pain. Because your boundaries and their contracts, they cannot be changed easily or as quickly as you could before. So you always also have problems or disadvantages in your runtime and deployments. So if you think about it, troubleshooting within a scaled system or distributed system, it becomes very hard because you're searching for a needle in a haystack, which leads that finding the root of all evil for a bug maybe or for misbehavior in a system becomes suddenly very difficult. And one thing I pointed out at the monolith that having less attack vectors because it's very not very open system now comes here on the other side, right? Because you have more distribution, you must have more boundaries in your system. So you're more exposed, which brings you to be more vulnerable to attacks and open attack vectors to the system. So let's have a short recap here. And please, I want you to hear this. Please do not follow any hype trains blindly. I think this is pretty crucial. Always choose your architecture and your style of software and adapt over time. Microservices, they truly bring modularity. That's true. They loosen coupling drastically in a system, and they're very neat to have working on with bigger teams and bigger systems, but they also bring contracts or boundaries with them. And on one side, yeah, you have your teams, which may work more independent, but on the other side, they bring a lot of technical complexity, which is most of the time pretty underestimated, I think. So I talked about this migration path we did. So I talked about this strangler fig pattern, and well, what I want to show you is how we did this, or how should you or could you migrate from a monolithic application to a microservice architecture, for example. But as I said, there's this strangler fig pattern, and it comes from this strangler fig plant. It's a subtropical plant, and it's a very nice real-life analogy. I really like it because this plant starts growing from the top of a tree, and it starts growing all the way to the bottom. It covers the entire trees and strangles it. So after time, it becomes possible that the original tree below or within this strangler fig plant could die, and the strangler fig still lives on. So if you think about it or look about it from another way, this is exactly what we did, right? We took our monolith down below, and we created this strangler application on top, which was our microservice architecture, and we transitioned part for part, right? It was very crucial to find nice little cuts in the old application where you could extract a single piece of software and move it out and make it a single service. So we refactored these parts that long until the old application suddenly got redundant and we could remove it. So this is a nice little migration path. So I want to do a short little recap about technical changes. I want to talk a little bit about Quarkus and what I so-call this resource greed. I want to talk about this, that asynchronous was the way to go. I'll talk a little bit about dynamic infrastructure and automation in daily business. So, well, I think this is pretty nice. The first thing, and I think that most of you guys know this illustration if you have been Googling about what is Quarkus or doing your research. And I think it's the first thing anybody ever sees about Quarkus when he searches for information in the internet or the website. And first thing that happened to me was questioning, well, does it even matter? And I think that maybe if you're thinking about like the normal old dev mindset, maybe not. But if you start thinking about all the time of your resources and your startup time in your memory in your cloud native environment, all of a sudden Quarkus it just made us or made me think smaller, right? Well, that's what it's about after all. So Quarkus made me think about building smaller services using smaller or fewer dependencies when creating new projects or new microservices. So this rethinking about thinking smaller, it brought a certain resource awareness to myself. Suddenly we, the team, cared about the memory we used or the startup time we had. And I think it's pretty neat because these cloud native values, they become suddenly pretty important. And after some time, which was very funny, this resource awareness became literal resource greed of mine. And I felt like similar to Gollum talking about my precious little memory or startup times. Well, yeah. Another thing that I want to point out is that in distributed systems or in communication in general, you have two ways to go, right? You have to go either synchronous, and you can compare it to a telegraph of the old word, right? Because when you want to communicate via a telegraph, you have to wait until your other partner is available and ready for communication. When he's ready, you could communicate, you have to wait for the answer, and you say goodbye. And after some time, there was this invention of this mail technology or email, for example. And it made us go in communication more reactive, right? I can, for example, give bad news to anyone without even facing them or without even them being there. So the opportunity you have or the advantage you have, you can send your messages or your news to people whenever you want. Your partner doesn't have to be available. The only thing that needs to be there is the infrastructure. So obviously, the asynchronous communication reduced the coupling drastically. And we have to say that it increased our system robustness massively because we all of a sudden had these buffer zones which were held by the message broker. If we had a lot of traffic on one side, we could simply follow you through his messages and didn't get overrun by any traffic. One big thing I want to point out is that this entire OpenShift revolution or technology we use, this is genius, right? We had all our infrastructure as code, which was very important to us because all of a sudden we had this very fast provisioning. We could create or delete infrastructures or environments within seconds or minutes. And one thing I want to point out with this infrastructure as code approach and also with the daily handling with OpenShift, it really enhances the dev know-how, right? Because all of a sudden the developers writing features or new services, also writing the infrastructure as code, they suddenly care about the operations behind it. And within the network, it really simplifies the communication internally drastically. Last thing I want to point out is automation. Well, we have to say engineers or developers, in my eyes, they should always be lazy, right? I really hate to do a manual task more than once. So every task I have to do twice, I'll normally automate it. And I think it is what we did in the project, right? We did not only have our build, test, and deploy stages in build pipelines, we had almost every step in the project we had to do manually, we had automated. So for example, setting up new infrastructures, tearing down old infrastructures, copying database, etc. And this is where OpenShift and also the command line interface of OpenShift and Kubernetes really helped us. So yeah, that was it. So thank you very much for listening, guys.